From Alex about testing PLC programs. So in this video, I'm going to show you how to test PLC program, let's say for something similar to this mixer plant. So that is an example. So it is simplified, and I'm going to show you how to test. So the video is all about the testing and how you can make it easy and quick by running in PLC Logic Prover. But before that, I'm going to show you that is application has one subsystem, liquid supply or fluid supply, a tank or mixer tank, which is subsystem 2, with the pump 2 and solenoid 2 including, and 3, it will be overall application. So you can pause and read how the control requirements should work, so how the system should work, what protections here, and what IO system we have. And also all files and all materials I'm using today is going to be available, and it is down in the description. So let's go to the PLC and see what the PLC looks like. The PLC has the main routine as usual, where we have all the subroutines called. I have that specific test bit where I can disable or enable particular routine, which is I'm using in my testing later. Also, you can see I have these 3 subsystems I just described, where it is fluid or liquid supply, mixer tank, and main system. So the next step is to show you how we can test this. So to test that, I'm going to close that and open PLC Logic Prover. So when PLC Logic Prover loads, it will show me, and it's showing me already the test case. And a test case is basically a tree of all tests is going to be done. And you can see it's a folder sign, it is action set. So it's not actually the test, it is set contains the tests. And every single test has particular task, or it's called action type, action unit type. So we can set bits and numbers and integers. We can toggle particular tag into particular values. So the combining them together, we create comprehensive tests routine, which runs completely automatically. So to run this, I'm going to click Test Run button, which opens another window. Where that window is going to show me the process of the test. So I already set up that way that is it's on the right side of my window. On the left side, I'm going to have my PLC program, so you can see how it works and how that triggers their particular bits. And when I will try to show you that as we go where and which routine it tests right now, and I will try to follow that, but it goes pretty quick, so I probably miss some bits. Let's run the test. Press run button. As we can see, it goes through the test presets, go to liquid supply presets, liquid alarms. Next is trip to pressure loss. So as we can see, it's just flickering bits in our PLC. Let's go to the supply, liquid supply, and we can see that it's running, have a pressure here, no fault. We can see the test reset bit is flickering from time to time. Now we're already in a mixer tank, so that's already missed 2 things. So as you can see, in some cases, we have these alarms going on like this now. We're tripping on flow loss, and it is indicated here on the test output log. So it goes pretty quick. So now it is already in the main. So if in main, you can see it goes through some states. So 3, 4, and 1, so 0. So it is changing states and going through the states. Now it's enabling the entire PLC and going through the IOs. So it is triggering inputs and input values. So particular here in mapping, it's just triggering these inputs and that values, and that way it can simulate the operation and simulates this and tests everything as per the functional description. So as we can see, it's went very quickly, went through lots of tests in just 1 minute. It's completed completely automatically. So it went through all these tests without any human interaction. So we can create the build, we can create and build the test cases and run it before modifications and after modifications. So make sure the integrity of the PLC code is the same. So what I'm going to do now is to explain some of the action sets. Let's go up some way here, let's say liquid supply preset. So how it works. First of all, we need to create the healthy state of this liquid supply, fluid supply subroutine. So the way how I write PLCs usually create the subroutines when I can disable or enable PLC subroutine. So in this case, I can disable all of them, enable only one, and only that runs. So in this case, I need to have few inputs and few outputs. So what I do in this case, I am enabling that particular subroutine after I making healthy thermal overload for pump 1, creating pressure 0, so no pressure yet. We don't want to have run request, so it's 0, and reset should be 0 by default. Next, we're pressing reset button. So how does it look in output log? Let's have a look. So here, when we set the healthy inputs, what does PLC Logic Prover do is to what does it do is to create the right to these particular tags and indicate it here. So what we did, we thermal overload went to 1, so it makes sure it is all healthy. And when it went for all these healthy inputs, it's press reset, so that becomes healthy. So that output becomes healthy. And next action set here in liquid supply alarms, we check that it's healthy, that's correct. And next one is we simulate the fault. So we're removing this thermal overload input. So we're putting this to 0. And what do we expect that? We expect that in 50 milliseconds, we're going to have that output is in fault condition. So that's exactly what we're doing. We have output in fault in 0 in 50 milliseconds. But as you can see, it is not exactly fault condition because fault should be 1, but that will be disappear. So the whole subsystem will be in fault. So I showing here as example, but also you can like in next step when we're doing trip on pressure loss, we requesting run, but with still zero pressure, and zero pressure was set here in the beginning when we have set healthy inputs, went the pressure to 0. So when we run request and pressure is 0, we expect fault comes up and healthy disappears in 3 seconds. So that's exactly, it will test exactly this run in this subroutine. So we send a run request without pressure in 3 seconds, we're raising the fault and removing healthy bit. So in the log, it will show you like this. So basically it shows me that we check healthy state, trip on TL, I already spoke about it. So that's trip on pressure loss. So when we have a run request is 1, we expect healthy goes to 0 after 3 seconds, and pressure loss goes to 1, pressure loss fault, I should mention, goes to 1 after 3 seconds. And also I should mention that is we can monitor additional bits or integers or reals, so it makes sure it doesn't change. So we continue monitor, it has been changed. So we can add the other healthy bits or particular values which should be maintained unchanged during this test. So that's how it works with within Test Builder. That's how we create. It's a quick explanation of, I'm trying to be very quick here because I'm going to show you how to create the test from scratch. And we're going to just do a little bit of this IO preset. So I'm going to show how you can do this just with your PLC right away and create some of tests already by just simply downloading and trying to do this. So what I'm going to do, I'm just going to close this unnecessary windows. So keep this window open, and I'm going to start with creating a new project. To do that, I need to click New button and New Project. Let's give it a name. Mixer Plant IOs. Let's create a project. So now I have empty test case on the left, start page. So I need to add action sets. Let's start with the first action sets. Let's give it a name. Let's say IO testing presets. Click the save button. So what do we want to preset here? That is usually dictated by the functional specification or system IO list. Or if you have a PLC already, you can open input mapping and see what particular inputs you would like to trigger. So in our case, we're going to try and we're going to use all the inputs. So we have to list all of them. So for this, I'll go offline and I'll start with this by adding these inputs to my program. So how I can do this is going to go to set tag value, where I'm going to say set healthy inputs. It's going to be in this set, and it's on the last, it's only one. So here I need to write that tag to a number. So in this case, I see that is to make this healthy, I need to have start is 0, stop is 1, as it says stop OK, so it is normal state. I'll have to reset is 0, and all this thermal overload protections, they have to be on too. So I can do two ways. I can add the tag name right here, and it is, gives me an option to create this because it couldn't find that. So that is what I'm going to use, and it's created already successfully. And as we know that the 0 is our start, and we just need to put start to 0. But also we can do tags through the tags page, where we can add the tags by clicking add, and after giving the name, enter, and add one more. We can do all of them like this. So let's do this. And 5. As also we know that it's going to be all Boolean, so we don't need to change data type. With these particular values, where you have inputs, analog inputs, is going to be analog, and it's going to be int, or in our case, it's real, right? So we're going to add one more, which is going to be real, and one more, which is going to be real too. So also I would like to give it its names so it's easy for me to navigate it later. So I'll say it's a start. Next one is going to be stop. Okay. This one is going to be reset, if I remember it correct. I'll just open this here. You'll see it's reset. Pump 1, pump 2, and mixer thermal overloads. So pump 1 TOL, pump 2 TOL, and mixer thermal overload. And with analog inputs, this input is pressure and level. Right. So now coming back to our set health inputs, and what I'm going to do, I'm going to set all of these inputs, all of these digital inputs and analog inputs to value what I want when it starts. So let's press this add button, and we're going to add stop. We're going to add reset, which is that. Also, we're going to add pump 1 TOL, 2, pump 2, yes, that one. Mixer, thermal overload, pressure, just collapse this, and level, right? So the pressure should be 0, level is 0. It's everything where we just start. Don't remember this. I think it's start here. That is, if we go back here, no, it's stop and reset until. So it's stop is 1, reset is 0, and all thermal overloads once. So it's done. So we just press save button here, and one of the test action units already added. Let's add another one. By adding another one, we just need to make sure that is we need to add right one. So it's going to be I think that one's what we need. I'm just thinking that is where another input is. It's our totalizer, which has Modbus connection, and it has heartbeat, where if I go to the PLC, I will find it in input comms, and I can see that there is a heartbeat where if that disappears or heartbeat is not active, it triggers the communication fault. So what I want to do is to go back and create heartbeat, which is going to say totalize comms, healthy comms. Totalizer. Healthy comms. So I will put it in the end. In this case, I need to have another input, which is I will going to use that tag, which is not written by anything in the program, so it's good to use. Let's put it here. Create. It's going from 0 to 1 every second. So it does say 2 seconds, so we can increase it by 1/2, so every 1/2 so will be triggered. We don't need to run particular time, it will be running during the entire test. So we press save button now. So when we have healthy inputs set, we probably need to press reset button to send all this to reset all these faults which are currently in place due to missing inputs. So next thing is going to be add action, and next action is going to be reset tag value. So it's very easy to call this, and let's call it press the set push button. And here we need to have reset input, which is input number 2. and we toggle to 1 and hold, let's say for 1 second. It just simulates human's direction as the person press reset button. So that preset's completed. If we need, we can run this just to test. So that's what I'm going to do. I just press test, and I'm going to open the PLC program. I can go online to see how it's going to behave, and I press run. So it opens connection. And as I can see, it doesn't open connection because I forgot one thing. And one thing is to set IP address, where I need to put the IP address of that PLC. And as you can see, the PLC address is here, right here. So 98.1. So close. And now if I'll run it again, I will see that it is going to preset all our initial steps. So it runs, it's connected, it set the tags, and now it has it set healthy inputs, action, it called the action healthy comms, press reset button. So next step is to create testing for the static alarms. That's how I call them. So to create static alarms, I'm just going to clear this, minimize that, and I will start with action set. Adding action set is easy as before. I just need to give it a name. I call them static alarms just because they're not into the process of controls. So some alarms we'll be doing only when we're doing controls, but a few of them, like thermal overload, we can test independently just by triggering these inputs we set to input which creates the fault. So let's start with this. But before we creating any test, let's make sure it is actually healthy. So it's basically we need to check healthy state. So to check healthy state, we need to add the tag. And if you go to PLC and go to the main healthy state, we can see that has a tag called system healthy. So what I'll do, I will just copy that and I'll paste it here. So I'll create this. And what it needs to be? It needs to be 1. So now when it's all done, I can run the test run again to see if it actually all my presets working correctly, and they eventually the state becomes healthy. So to do this, I'm just clicking as usual test runner and run the test. So that way we can see it's passed, it's checked, system health is 1. So basically all our presets are correct. Next thing, I'm going to add some trips here. So first trip I'm going to add is going to be, I'll call it trip. So easiest way to give it a name is to what it should do. That's my question. What it should do? It should trip on pump 1 thermal overload. Right. So that is the name. So here I need to do the following. I need to remove thermal overload input. So by searching right input, I will have to set to 0. And what I'm looking for the system to become unhealthy. So I'm expected output is the system which we just checked. It should become 0. And as I'm creating this expected output, I need to make sure what time it takes to trip this. I have two ways to check this. One of them I can check directly in the PLC, so I can see there's a timer for 50 milliseconds, or if I have functional description or functional specification, I can look in the functional specification where it says loss here we go, motor thermal overloads. They're all for 50 milliseconds at 0. So here we have 0 and I have 50 milliseconds. So it's basically going to be 0.05. When it's completed, what we need to is we need to press reset button so we can go to the next test unit. When we finished, we press save. So I can run it again and see how it worked. So we can see when we press reset, it becomes healthy. And after it's healthy, we removing the thermal overload input, and we expect that this system healthy will become 0. And it's exactly what's happening. I can open the PLC, run in online mode, go online, and I can see this pump, and that timer should flick from none to 1, and which will be eventually trigger this fault. Let's run it again to see it's in the PLC. So as we can see, it's completely automatically did the check for us. So that is the way how you can create your PLC testing, and that is how you can get started and continue creating all your test routines and automatically run it when it's needed. And that's it for now. Bye.